So yeah, today I'm going to talk a little bit about how we're seeing agents getting used in production today by large software engineering organizations. A little bit about myself. My name is Robert Brennan. I'm the CEO at OpenHands. And at OpenHands, we do, we have a platform for coding agents, being able to run those agents at scale within software engineering organizations. My background is in a mixture of dev tooling and natural language processing. I've spent the last 15 years or so working specifically in commercial open source developer tools. But a little bit about, kind of how we got to where we are today. Things really started with people basically chatting with ChatGPT and realizing that, hey, it can write some code. I remember the first time I asked it to write a bit of SQL for me, and it spouted a perfectly valid SQL query, and I was able to paste that into my IDE, and I was blown away that this AI could write code now. But it really just started with me pasting code back and forth between my IDE and then getting error messages back and pasting that to ChatGPT. Fortunately, we pretty quickly figured out, hey, we can just wire this up directly to the IDE, and we got things like autocomplete. The AI could now see inside of our code base and write, lines of code that were contextualized to the code that was already there. But a big leap forward came, about a year and a half ago, when everybody started working with agents that could not just write code, but could run the code that they wrote, could Google an error message that came out of the code, basically do that whole inner loop of development, in a fully automated way. That was a huge, huge leap forward. But now we're kind of hitting this wall with local agents where you can still just do one or two things at a time. I'd say developers are still kind of working the same way they used to a year ago or 10 years ago, where they're picking up a ticket and they're opening up their IDE or their CLI and they're squinting at their computer screen and trying to figure out how am I going to solve this. The agent helps them go maybe 20, 30% faster, but it's really not the world changing, lift in productivity that we've been promised. So the next big leap is really when you start to get coding agents that work in the cloud, that are working in the background, that are working proactively rather than being prompted by a developer. Once folks make that leap, we see agents starting to work together. Agents, one agent does an implementation, another agent reviews its code, another agent does QA. And then, at the end of the road, we're seeing full automation of the SDLC. So a little bit about this barrier that we're seeing today between the local coding agents and the cloud coding agents. This first loop, the inner loop agent is probably the workflow that you're used to if you've used Cursor or Claude Code, where you're picking up a ticket and then you're manually prompting an agent and doing this tight feedback loop between you and the agent where, the agent makes some changes, you take a look, the agent makes some more changes, you take a look. That's great for things where you don't really have a clear definition of done, you're still exploring the problem space. You kind of want that tight feedback loop. But there's a lot of software development tasks that are fully automatable. They're very rote. They don't involve a lot of creativity or critical thinking. And that's where, those are the types of tasks that are really ripe for full automation with agents, where you can really get agents working asynchronously in the cloud, kind of in the background and just doing this work for you without it having to take up space in your brain. A few examples of sort of how these outer loop agents get driven. I would say the sort of easiest and most familiar pattern is with a manual prompt. But here, instead of typing into your CLI directly on your computer, please do X, Y, and Z with this, version of the code that I've checked out locally. Instead, you're inside of Slack and you're saying, hey, at OpenHands, go fix the bug we were just talking about. Or you're inside of a Jira ticket and you just tag that ticket and OpenHands comes in and starts working on it. You're basically pulling the agent into external systems where there's already this context about what do we want to build and how do we want to build it. The agent can just pick that up and run with it in its own cloud-based environment. You don't have to spin anything up locally. I'd say one step beyond that in maturity is being able to run things on a schedule, right? Maybe every Monday morning you have an agent that kicks up and tries to update all of your dependencies. Or maybe every month you have an agent that starts up and runs a pen test against your environment. There's a whole bunch of stuff you can do with scheduled agents. But the most power really comes when you start responding to events in external systems. This is really when you start to build an ecosystem of agents that are working on your behalf, right? You can respond to errors that are coming out of Datadog. You can kick off an agent anytime a pull request gets open to do a code review. Or anytime the CI pipeline fails, immediately kick off an agent to fix the CI pipeline. Or maybe anytime a Jira ticket is opened that has, it's an easy story. There's very, very few story points. Just immediately kick off an agent to investigate or to solve that issue. So you can see some examples here. On the manual prompts, it's usually about, hey, we've been talking about this bug in Slack. Just like go fix the bug we were just talking about. Go fix issue number 42 in GitHub. On a schedule, you could do things like performing dependency updates, performing an architecture review, making sure that all the changes that have gone in fit together nicely. You can have the agent suggest refactors every week to try and like get your team to keep the code base healthy. And then one that we love internally at OpenHands is anytime there's a 500 error in Datadog, something unexpected happens in Datadog, we kick off an agent to go figure out what went wrong and start to basically push a pull request with a fix. In terms of how these outer loop agents are defined, I would say most naively, it's just a prompt, right? You can just say, hey, look at the Datadog logs. If there's an error message, then go to these repos and figure out where to edit. And that works, like just throwing a prompt at these agents. But it's much better to find these agents in code. There's a lot of the process that is going to kick off every time this agent fires is very deterministic, right? In that Datadog example, the first thing we want to do is just reach out to the Datadog API and do the exact same query every single time to pull the latest error logs. The agent can do that, but you're going to burn tokens doing it. It's going to take longer to like hit an LLM and have it write the query to go to Datadog. So it's much better to write some code that builds like kind of a deterministic process around this agent, and then only kick out to the agent when you hit the fuzzy non-deterministic part that's harder for the agent to execute on. So defining these things in code is a much more powerful, much more scalable way of doing outer loop agents. Over on how to get started and how we see existing organizations getting started with running agents in the outer loop. They start where the bottleneck is, and I would say today the bottleneck is in code review. It's in QA, right? We're generating tons and tons of code. Agents are opening up tons of pull requests, but those are getting stuck in the pull request phase because we don't have enough engineers to review that code. Somebody needs to context switch over. Somebody needs to download the actual application and run it. And so a great place to get started is to just have agents that automatically review that code and automatically QA that code and post to the pull request any updates that need to happen. We will even start to have agents approving PRs so that if it's a pretty trivial PR, I'm just changing the README, I'm updating some comments, I can get a quick approval from an agent rather than having to wait for another human being to like context switch over and look at my work. So we're seeing some organizations start to experiment with pull requests getting in so long as it passes an agent's code review rather than making another human look at it. I would say the next level of maturity here, when you really start to move a lot faster with these agents, is where these agents are essentially opening up PRs, getting approval from another agent, and then merging their own PRs. This is a little scary that there's no real human in the loop here, but for like very constrained problems, this is actually a very achievable thing today. So like things like dependency updates, you can really trust the agents to do the right thing, right? You can have an agent kick off, updates the dependencies, another agent does a QA pass, and if everything looks good, only certain files were changed, you can allow it to kind of auto approve and get merged in. None of your developers now need to like context switch over to this thing and just like look at a bunch of numbers changing inside of your package.json, right? There's a lot of small tasks. Unit test coverage is another great one where you can just have agents doing full automation here. You don't need a human being to like sit down and think about this problem. The agents are good enough to take on those kind of tutorial-y tasks that the developers are doing. And then at the run phase, we're starting to see what we call the dark factory, right? These repos where the repo is entirely agent managed. We have one internally that we've targeted for this. We're not quite there yet, but it's a TypeScript client for our REST API. It's a very rote repo. There's not a lot of creativity or critical thinking that goes into this repo. It's kind of like look at the upstream changes to the REST API, implement the TypeScript client to do that. It's a very rote process. Right now, we pretty much are just manually poking agents to do it. It won't be too long before we just have a fully automated process where agents are doing the entire SDLC for that one repo. I mentioned this idea of a dark factory and, this idea of a repository where agents are doing everything essentially, right? They're shipping code to production. They're monitoring the production logs to make sure it's doing the right thing. Maybe they notice an error path in the production logs, open up a new pull request to fix that error, get that merged into prod, verify that the error logs went away, right? They're able to do that entire software development loop, both the inner and outer loop. And I think the question that comes up is like, well, where do humans fit into this process if agents are doing everything? And there's two quotes that I love here. One is from Picasso, and he says, computers are useless. They can only give you answers. And I think that's just as true today in the LLM world. as it was back when he said it. LLMs are great if you give them a very like constrained problem and say like, this is what I want you to do. They'll go off and do it. But if you try to like get them to design your roadmap from scratch, they'll just make up a bunch of stuff, right? They don't really have any vision for your product. They don't understand the constraints of like, what do we want to build? What do we not want to build? They don't have any empathy for your end users, right? And so there really is going to be a very strong role for product-oriented folks to talk to users, figure out what do we want to build, what do we not want to build, and basically be the roadmap input to this system. And then on the other side, the other quote that I love is from IBM in the early days of AI. And they said, a machine can never be held accountable. And therefore, a machine should never make a management decision is the rest of the quote. And I think the way that comes into play here is this complicated system, this dark factory, it's going to fail in unexpected ways, right? You're going to have cost overruns, production's going to go down. You're going to want to have humans that you can hold accountable, right? That you're going to have somebody who's a good systems level thinker who's going to be responsible for this ecosystem of agents, making sure they behave well, making sure they do the right thing. So I think there's always going to be a role for those systems thinkers, to basically, maybe you'll call them robot psychologists in the future instead of software engineers. But I think there's very much a place for humans that we can hold accountable for these very complicated systems. A bit about like how to build for the future here. I think the biggest thing is to build a foundation that you can start to really customize the developer experience at your organization on top of, right? So at OpenHands, we provide a bunch of like baseline cloud infrastructure for provisioning sandboxes for agents, connecting them to secrets and MCP servers, basically doing all the like undifferentiated work that you need to do to get agents running at scale. And then we allow our customers and our users to define kind of like that last mile. What is the developer experience going to look like? What is the user interface for this going to look like? They'll build, everything from custom automations that are like firing in response to events coming out of GitHub and Slack, to even like custom chat interfaces, custom user interfaces, custom web apps that use our agents under the hood. And I think having that kind of like baseline platform that you can then experiment on top of really helps you stay future-proof, right? It helps you build a developer experience that makes sense today. And then as the technology gets better and better, you can evolve the developer experience over time by leveraging that same base infrastructure. The other piece is really making sure that you have some kind of centralized control as well as visibility into what these agents are doing. I think a lot of organizations today are struggling with what is being termed agent sprawl, right? Every developer is running a different agent on their workstation. Some people are using Claude Code, some people are using Cursor, some people are using OpenHands. And the company doesn't really have any sense for like, who's just burning tokens here? Who's actually delivering ROI? How many of these agents are actually like connected to our production databases versus like nicely isolated inside of a sandbox? And once you get all these agents like running in the cloud, you actually start to get some visibility into what these agents are doing. You get some control over being able to, decide what secrets they have access to, what systems they have access to, what they're allowed to do. There's a lot of nice things that you get once you start to centralize control over these agents. In particular, I think you can start to see which of these agents are actually driving ROI for us. Like you can see, hey, our code review agent, it has an 85% success rate, and it's costing us this much money. Therefore, it's delivering good ROI. But this other agent over here for fixing bugs, it's only getting 10% of its PRs merged, and we spent, $20,000 on it last month. Maybe we should just kill that one. That's all I've got. But if you want to learn more about OpenHands, you can check out openhands.dev, or you can check us out on GitHub. We've got a software agent SDK repo, which will allow you to build agents in Python that respond to these events coming out of third-party systems. Thank you all.